Hello and welcome. This is question 5 for Mechanics Unit 1 for Edexcel, November 2002. So this question is a mix of Subat equations and force equals mass times acceleration and a little variation on that last point I just made there. Okay, so what I've drawn for you on the board here is sort of a summary of the bits of information that you get given. So this is preferably what I draw on your page if you're not lazy, but I am. So I can't really glue the exam paper to the board as much as I'd like to, because I mean that's work for me. But whatever. So as I said, this is sort of a summary. So this take G to be 9.8 meters per second. That's given on in front of your exam book. But I've done that because I'm assuming you're probably not going to let up or can't be bothered to look it up, but it's fine. It's in physics 9.81, but it's not going to make much of a difference. But you might get a cruel examiner who goes, "Oh, I don't like that. He's used 9.81 and not 9.8," even though it's more correct. The examiner's a bit in the head. But if you're marking my exam, then you're really good. We're also told the mass of the suitcase is 10 kilograms. Now, a key thing. They wouldn't necessarily do this in maths, you might do it in physics, but it's just a point. When they give a mass of something, you need to keep it in standard instrument units, or scientific instrument units, SI units, sorry. And they are, in mass it's kilograms, or force it's newtons, or acceleration it's meters per second. So you need to keep them in that kind of form. But as it's already in kilograms, you need to change it. Now this first point, we use these two features here. So we're told the initial speed is 5 meters per second at A, and the final speed at B is 8 meters per second. Now we're asked to find the deceleration of the suitcase. Now one thing I would stress, I'm not bothered that this is an inclined plane to start with. Now this does have some resistance, but we're not really bothered at this stage of the question. So part A, we're not really bothered about that. It could be anything. So we can almost imagine this to be a level horizontal line for the moment, but it's just at a weird angle. We will consider the angle later on. We need to work out the deceleration of it first. Now, so we need to write down what we've got. So what I'd write down for part A, I've already done this sort of here, but if this was your paper, you'd go, okay, well, so for part A, U equals 5 meters per second. V equals 8 meters. Is that a way around? Oh, sorry. At A, it's 10 meters per second, not 5. Just about to say. That's how long the day's been. So U is 10 meters per second, V is 8 meters per second. And we are told the distance A to B is 5 meters, so S is equal to 5 meters. And what we want is A. Now, we could do this a number of ways, because as with maths, there are always a number of ways of getting to an answer. There's one way, which is the slightly longer way. So this is the one that some of you might have spotted. You go, we've got U, V. So acceleration is A equals V. V equals U plus V equals A plus V equals U plus AT. Sorry. So therefore we need some T, and if we've got S, U, and V, the only equation that links S, U, and V with T is S equals a half of U V times S equals a half times U plus V times T. To find T, and then you could put that value for T into your A equation and find out what A is. Now there's a reason I've not done that. Not because I'm lazy, although that is the case. It's because that's not the one I choose. Now what you want here is A, and we've got V, U, S, and we need to find A. Now the only equation that links V, U, S and A is just them, is V equals U squared plus 2AS, which is exactly what we're going to use. The first thing I always do is write down the equation. So V squared equals U squared plus 2AS. Now you could at this point, now obviously A is going to be negative, so what you really should be writing is V squared equals U squared, take 2AS because A is negative. However, I wouldn't write this in purely because it's quite easy to think, oh, well, A is minus there, so it's V squared equals U squared. Take 2AS, but forget that you've already added that minus sign in. So when you find out that A is negative, you're going to be taking away a negative and say A is positive when it's not, because it's deceleration. So I'd leave it like that. You're more than welcome to put a minus in there, but I think personally that just confuses you. So, put in what we know, so that's 8 squared equals U squared, so 10 squared. Now I put meters per second squared, but I'm not really, should put that, meters per second squared, plus 2 times, I just put 2 brackets A, close brackets, open brackets, S, 5 meters. So if we rearrange this, so that's 64 meters per second squared equals 100 meters per second squared plus 2AS, so that's 2 times A times 5. Okay, so we simplify this down, so I take 100 meters per second away from both sides. That's minus 36 meters per second squared equals 2 times. Sorry, my computer has just decided at this moment to die. So that's 36 meters, minus 36 meters per second squared is equal to 2 times A times 5. So if we sort this out, so therefore minus 36 meters per second squared is equal to A times 10. Rearrange this, so therefore A is equal to minus 36 over 10. So A is equal to minus 3.6 meters per second squared. Okay, so that's the value for A. So that's quite crucial for the next part of the question. As I said, with physics and maths, they like to use previous parts of the questions to enable you to answer the next part. Okay, so the next part says the coefficient of friction between the suitcase and the ramp. Now what I'm going to do is I'm just going to move these bits of information so I can draw sort of a simplified version of that. If I can find where I just put the rubber. Actually, that's it's always the first. It's always the last place I look. That makes it sound stupid, really. But, you know. So remember we said G was equal to 9.8 meters per second, and the mass of the suitcase was 10 kilograms. So I just put M equals 10 kg. So what I'm going to do is redraw this diagram. No, right, that's not very good. Redraw the wrong diagram. Put theta. Okay, so if we draw the forces that are involved in this, so we're assuming we're at B now. It doesn't really matter, but we know what the deceleration is. So if we draw this block on here, so what I'm going to do is, like I did with the previous question, question 4, I'm going to draw in some kind of force diagram because I'm rubbish at drawing. So we have a normal reaction force, M, and we have the weight acting down, which is mg. And if it's parallel to the slope, for reasons I've gone through in a proper video, that's mg cos theta. And parallel to the slope in the direction it's going is mg sin theta, sorry. And obviously back up the slope, therefore, is the resistance force. Now we did do a proper video on this where I said normally you calculate the resistance force as just the resistance force, we just told that, but this this is the resistance force, F little r is equal to U r, or mu times r. Now we said this U was the coefficient of friction, r was the normal reaction force, so therefore we said Fr equals U or mu times mg cos theta, r being the normal reaction force, so N is equal to r. So essentially that's what we've said, and if you don't get how we've come up with that idea, then please do revert to one of our early videos, probably not even online by now, but refer to a video that doesn't exist, which is obviously not my fault at all, it's YouTube, or more to the point my computers. Obviously my computer and YouTube had a big falling out, and it's ended up with me not being able to upload videos, so I'm probably just talking to myself right now. So it's all good, I can do whatever I want. So anyway, how does this help us to find the coefficient of friction? Well, we know what A is. So, obviously, R and mg cancel out because the suitcase isn't sinking into the ground, unless someone like me comes and punches it into the ground. which is entirely likely, especially if it's the suitcase of someone who has what's the word I'm looking for? Well, I can't say it on YouTube because I'll just get beeped for it. So you can imagine you fill it in, and I will get beeped. So anyway, as I say, you know, the horizontal and vertical force. Sorry, the vertical forces are balanced. So it's only the ones that are parallel to the plane that we're concerned about. Now, obviously, FR can never, as we discussed in that other video, FR can never be greater than, well, can. Like, you know, actually, I went against my own rule there. I'm going to have to do another video. Right, anyway, FR can be greater than mg sine theta. Because if it's slowing it down, if it's got a resistance force, then it's going to be slowing it down, so FR is going to be greater than mg sine theta. If it's decelerating, as we're told it is. But obviously it's going to come to a point where FR equals U times R is, well, when it slows down, it's not going to stop and then go back the other way, because FR is always, so the resistance force is always opposes motion. So we can't be pulling it up. No resistance force can be in the direction of motion, because that goes against the whole idea of resistance forces. So it can't be pulled back up the slope. So it is greater initially, but obviously it decreases. Anyway, we won't get into that, because what we need to know is FR minus mg sine theta, or whichever way around you want to look at it. Doesn't really matter, because you're going to end up with the same answer either way. FR, in this case we're going to do F equals mg sine theta. So we should know, going back all the way, what I'd do, first thing I'd write F equals ma. Now you know what A is, so you could just write this in. So, and you know what m is, so you could put F equals the mass of 10 kg times negative 3.6 meters per second squared. And you could work that out, that'd be very nice. But I'm going to keep it as a 10 kg times minus 3.6 meters per second, because hopefully you kind of get the idea of where this is coming from. So, right, so what's now this force we said is the resultant force. So the vertical forces are balanced, so it's the horizontal ones that we need to consider. So this F is mg sine theta minus UR. Now, I will put in what R is, but I just want to do it in bigger steps. So equals 10 kg times minus 3.6 meters per second squared. So if we put in what R is, we know R is the reaction part, which is mg cos theta. So mg sine theta, you could put the numbers in for this, but I'm not going to just yet, because I like to go the long way around, because that's for longer. So mg sine theta take U times R, which we know is mg cos theta. Well, I'm just going to put in brackets mg cos theta, equals mass times acceleration, which is 10 kg times negative 3.6 meters per second squared. Now you could put, quite arguably, you could change that A to a D and put deceleration is positive. So it's either going to be acceleration is negative or deceleration is positive, both of which mean exactly the same thing. So a sec. So if you can have just go at simplifying down, well, I definitely don't use the moment to save my camcorder, because it's had enough, and I'm not going to let it because it's in the middle of a video. I quite like these videos, I have to say. Sad as that sounds. So I'm just going to give you a second, however long it takes me to sort all this out. So we need to have a go now. So you just put what mg sine theta is and mg cos theta. And obviously we know the mass is 10 kilograms. So one thing you could do, which actually gives me a bit more time to plug this in, is you could discontinue the m's. You could ignore the m's. But I personally think that'd get you in a bit of a tricky mess, to be honest, because you might end up cancelling too many or not enough, or I just simply put in the value of m, because you're going to get the same answer, or you should get the same answer either way. Okay, so calculator's happy. Switch it on, plug, that help. So anyway, plug in what you know. So 10 times, I'm just going to leave g, 10.9.8, I'm going to leave it as g. So 10 times g times sine theta, or sine of, in this case, theta being 20, so sine 20. Remember, keep it in degrees, because obviously you wouldn't have a radian figure that was greater than, well, you wouldn't have a radian figure that was a q and was greater than pi over 2. Take mu times mg cos theta, which is 10g cos 20, equals, I'm going to work this one out now, so there's 10 times minus 3.6, which is minus 36 newtons. Okay? Now if you'd have put mg cos theta in first, then you would end up getting the same answer as I said. So work this one out. So that's essentially, work this one out, it's 33.5252, etc. Take away mu times 92.183, so mu times 92.183. Now we'll just leave these answers in your calculator when you work them out, is equal to minus 36 newtons. Now if you simplify that down, you should get a value for mu, or the coefficient of friction, which states the coefficient of friction is equal to 0.75. Don't forget to put that in the correct form of saying, yeah, so I'd underline that, so it's 0.75. It's really 0.755, so put a little dash above that. Or if you wanted to put 0.76, that's perfectly acceptable as well. So what it says is, so part C says find the greatest possible length of AC. Okay, so we know the deceleration, which is minus 3.6 meters per second. So we don't need to worry about this coefficient of friction anymore. We don't need to work out this resultant force, because essentially we could do part C without knowing part B. So long as you've done part A, you could do part C, really. So part A helps you understand B and C. So if you didn't get part A, you're a bit stuffed. However, as I said before, if you don't know what A is, but you do understand how to work out B and C, then just put on your answer, let A equal whatever number it may be, and you will get some. That's increased actually. You will get some marks for doing some kind of method if you get the method right. But obviously you won't get a mark for the answer. You just won't be penalised twice, because you get carry-on marks like you do in physics, you do in maths as well. Okay, so as I said, you use part A. So obviously we're not for part C. So if we're answering question C, obviously I don't really have enough room to do this, so I'm just going to cram it on if I can. Or talk you through it. I think I'll talk you through it actually, rather than cram it on. So what we're going to do for part C, so make sure I've got my thing here. So we know, so what I do for part C is write down everything you know. Now it's not going to be entirely helpful, but if you write down everything you know, you're not going to miss anything out. So we know the force is minus 36 newtons. We know the mass is 10 kilograms. The acceleration is minus 3.6 meters per second, or deceleration. The initial speed was 10 meters per second, and now if the greatest possible length, we need to find the greatest possible length of AC. So that means it just reaches C. So if it just reaches C, that means it comes to rest at C. So if it comes to rest, then its final speed will be 0 meters per second. So this is just a case of finding what S is in distance. So what we've got is we've got the initial speed, we've got the final speed, we need to find the distance, and we've got the acceleration or deceleration. So we've got V, U, A and S. So it's a similar equation to that one. So it's the same one, except we just put V as 0, U as still 10, and A as minus 3.6, and we need to find what S is. So it's a very similar idea of working this one out. So if you put that in, you get V squared equals U squared plus 2AS. So 0 squared, 0 times 0 is 0. So 0 squared, or 0, is equal to 10 squared, which is 100. So 0 equals 100 plus 2 times minus 3.6 times S. So therefore, 0 is equal to 100, take 7.2 times the distance. So make 100, therefore 100 meters per second must be equal to 7.2 times S, or the distance, divide both sides by 7.2, so S in metres, the distance in metres, is 100 metres over 7.2, so therefore the distance is 13.8 recurring, or as it specifies in the mark scheme, 13.9 metres. If it's any greater than that, the deceleration will be too great and it will actually stop before C. Okay? Now it won't go any further because there'll be a resistance force holding it back, so it won't go up the slope but it won't go down, so it'll just be stop and stay where it is. However, if it was a smooth surface and it wouldn't have any resistance, so we wouldn't have any deceleration, so it would just keep going as long as you've got the slope going, still gradient constant. Alright, so that's how you'd answer that question. Hopefully that's quite a nice and simple one. That. So that's the end of question 5. That's just taking your F equals MA a little bit further. I hope I made my corrections from my video where I said F equals UR. I did make a slight mistake in that explanation, so I'm just going to add to that video now. Okay, so thanks for watching, and sorry about that. I did that a little bit. As I said, it was very similar to part A, which obviously I planned to do it like this, not just corrected it at the last minute. So, as I said, what I've just said in part C is on the mark scheme, and it's fairly simple. It's pretty much the same way I've explained it to you now. So, you know, part C. As I said, part B is the one you really needed me to draw the diagram, and I hope that diagram in the top right there, so just zoom in if you didn't quite see it, was quite helpful to you. Okay, so thanks for watching, and I hope you've got something out of it, and we'll see you in the next video. Thanks for watching.